Hello and welcome. What I'd like to talk about for a few minutes here is disk management in Windows. There are two types of disks that we can have. We can have basic disk, which they all start as, goes back to DOS, and we can have dynamic disk. The basic disk can have partitions. In the partitions in Windows, we can have four partitions. We can have four primaries or three primaries and an extended, but a total of four in the basic disk. Once we convert the disk, and we'll look at each of those things here in just a minute. Once we convert the disk, we create volumes. When we create volumes, we can do what we'll call the clever stuff with Windows, which allows us to do RAID. And the picture you see here is a RAID. It's showing a RAID level 0, and as the data goes through, we see up here that the data block comes in and gets split up into different components and then gets distributed across, in this case, the four drives. This is not a true striped disk array without fault tolerance, so it's not a true RAID. RAID being redundant array of inexpensive or independent disks. You will hear both of those terms. So we are watching the action here. The information comes from the computer, and it then gets split among the disk drives that are available. We click on it, click on the RAID controller, the data block, the A, B, C, D, E. That single data block gets split up among all of the disks. The advantages and disadvantages of RAID, or the characteristics of RAID 0, implements a striped disk array. The data is broken down into blocks, and each block is written to a separate disk drive. I/O performance is greatly improved. Gamers should love RAID 0 because it makes the read and the writes to the disks much faster. Best performance is achieved when the data is striped across multiple controllers with only one drive per controller. No parity calculation overhead is involved, and we'll look at parity calculation in a few minutes. Simple design, easy to implement. The disadvantages are it's not a true RAID because there is no fault tolerance. Fault tolerance means that I could lose one disk drive and the system would keep running. It would slow down, but it would keep running. Difference between fault tolerance and backup is that if I had fault tolerance and I lost one hard drive, it would keep running. If the computer blew up, the building went away, there was a fire in the server room, the fault tolerance would make absolutely no difference, because fault tolerance means that I can keep running, but if something happens to the machine, the data goes away. Backup means that we make a copy of all of the information onto a piece of hopefully removable media and store it someplace else off premises. Okay, so back to the disadvantages. Not a true. The failure of just one drive will result in all the data in the array being lost because it does not have any fault tolerance. It should never be used in critical environments, things that you want to be able to keep running with. Recommended applications: video production, image editing, pre-press applications, and any application requiring a high bandwidth. So that is our RAID 0. So let's go to the top of this page. This, by the way, is at www.acnc.com that have provided this illustration of RAID. So let's look at RAID 1, and as you can see up here, I'll jump around. RAID 1, 2, 3, 4, and 5, and 1, 0, 5, 0, and 0, 1. Lots of different things. When you create a server, we're obviously going to want some fault tolerance. The RAID 0 didn't produce any fault tolerance. RAID 1 is a mirroring or duplexing depending upon how many controllers you have. If we have a single controller, then we have mirroring. If we have multiple controllers, then we have duplexing. So let's see if we can get this one to run. Here we have the data parity, the data block A and B and B. So we're making copies of the data on these two different physical drives, and that's what a mirror does. It creates a mirror image or a copy of the data that we've put on one drive and copies it to the other drive. Characteristics: 1 write and 2 reads possible per mirror pair, which means that the write's probably going to be slower, the reads may be faster. Twice the read transaction rate. 100% redundancy of the data, which means that if one of the drives fails, then we have a complete copy kept all the time of all the data that we have saved. Transfer rate per block is equal to that of a single disk. RAID 1 can, under certain circumstances, can sustain multiple simultaneous drive failures. It's the simplest RAID subsystems. The disadvantages over here are it's the highest disk overhead. You lose half of your disk space because you're making a copy of everything, and it is going to be a slower write, but you should improve your read speed. Typically, the RAID function is done by the system software, so we get a load on the CPU. May support hot swappable, may not support hot swappable. Recommended applications: accounting, payroll, financial, any application requiring high availability, so that regardless of what happens, our information is still available. I'm going to skip over the 2, 3, 4 and skip to RAID 5. RAID 5 has parity generation. We're going to have striping with parity generation. Parity means that it creates a data file, and we see the parity stripes here, so that if we lose one drive, one physical drive, we can keep running and we can actually replace that drive and rebuild the parity. If we lose 2 drives, then we rebuild the RAID and restore from backup. So let's see if we can start this one here. We get the data block coming in here, and it splits the data up amongst these and then puts the parity block here on the last drive. The parity block has to be on a drive where none of the data is stored. So as we split the data packets up to again share them across all of the drive letters, the parity block is put on a drive where we don't store any data from that particular data block. So in this case, if we go down here, we got A0, B0, C0, D0. We didn't put any of the information from the D0 data block on the last drive. We put the parity stripes, which has information about all the data, so that if, for instance, the D block's drive failed, we could replace it and rebuild the RAID, rebuild the information. So it allows us true data redundancy. We'll go down here, the characteristics: the highest read data transaction rate, medium write, because we have to create the parity stripe each time. Low ratio of error correction, parity, the disks to data disk means high efficiency. Good aggregate transfer rate. The disadvantages: disk failure has medium impact on the throughput. If you have a disk failure, it will in fact slow down your data transactions, and you'll know that the disk has failed, hopefully, and you can replace it and rebuild it. Most complex controller design, difficult to rebuild in the event of a disk failure as compared to RAID 1, but you can still rebuild it. Individual block transfer rate the same as a single disk. So that's basically the overview of the 3 types of RAID that we're going to be concerned with in the Windows system: the RAID 0, RAID 1, and RAID 5. Okay, now that we have looked at the overview, let's look at some of the things that we can do with the Windows system. When Windows installed, this is an XP machine. When Windows installs, or when disks are initially installed, they are basic disks, as we can see here in the disk management of the computer management console. Basic disks, if I go down here to some unallocated space, I can create new partitions, and I can create a primary partition or extended partition. Logical drives grayed out because there are no extended partitions. If I create an extended partition here, let's do one real quickly. 250 meg just to have something. For an extended partition, I now have free space that shows up. Once I go back into the free space, I can now create the logical drives. If I create a new partition here, primary partition, and let's do 250 megabytes again, and assign it to drive letter quick format. Quick format simply builds the directory and allocates the space. A full format, if we did that, checks the drive for bad information. So now we have 1, 2, 3, and we do a new partition again. And let's do another 250. I'll do a quick format just to get it done real quick here. And now we have these, and once I have the 1, 2, 3, 4 and I right click, I don't have the ability now to do anything with my unallocated space. I can't expand it, I can't create new partitions, so I've now left a significant amount, 123 gig of unallocated space here, which is going to be unusable in the basic disk system. So let's go in here and convert these things. We have basic disks. If I convert the basic disk that the operating system's on, I'm going to have to reboot the system. Let's just go down here and pick on these. Let's convert all of our other disks. I have 4 other disks, 1, 2, 3, and 4, to dynamic disk. It's a matter of clicking on that, and then it says, okay, we're going to convert it. Are you sure? So now I'm going to tell it to convert. If you convert these disks, you will not be able to start other installed operating systems if I had an NT4 system, because it would not recognize the dynamic disks. Do I want to continue? Yeah, I'm going to continue. Will be dismounted. They have to be dismounted, then they should automatically remount once the system is done doing its thing. So we were going through and doing those. We are now converted to dynamic disk, and I have dynamic unallocated space. If I right click, I can now create a new volume, where before I couldn't do anything with those volumes. And if I right click on these, I should be able to extend the volume into unallocated space on the disk itself. So I could then I could extend it on disk 1, however much I want to extend. I can extend it to disk 2, disk 3. It has to be extended to unallocated space. So with the dynamic disk, we could go in here, and if we now wanted to make this volume bigger, we could extend it, and let's extend it to disk 1 and disk 2, and let's just put another 250 meg on these things, just for the heck of it here, and finish. We're extending. We hope we're extending anyway. On volume 2, as we look at this thing, G is now got, and I took too much space, didn't I? On these thing, and on this thing, when I look at G, I have now extended the G volume. Let's look and see what we got here on my computer. Properties is now 124 gig. Use space 34 meg. So I did extend it. Well, I originally created it, if you remember, as a 250 meg partition. I have extended it to be 124 gig. If I want to make that go away, I can simply go in here and delete the volume. Do I want to continue? Yes. Away. I'm now back at the differences between the dynamic and the basic disk, because when I had the basic disk, remember, I could just create the basic volumes, and when I go to new volume, I can create a simple volume, a span volume, or a stripe volume. So I can use a striped, and I need at least 2 disks, information from 2 disks, in order to create a stripe volume. You notice that I can put space in here, but I don't have a next until I put something else in here. Now let's say that we want to do 250 megabytes from each of these, which gives me a total of 500 meg. And we'll do a quick format again. Finish this up, and it's now formatting. I have a G drive that I have created, new volume, so that we now have a striped volume. Again, striped volume, remember, makes the read and the writes faster, does not have any data redundancy. And if we look at the possibilities in XP, none of these have any data redundancy possibilities. I've now shifted to a Windows Server machine, and we'll take a look at what we can do with its disk management. It gives us a lot more flexibility, capability than does XP. When I go into this one, I have unallocated. I've got disk 0, 1, 2, 3, 4. I have a bunch of different disk drives here. The first thing that we can convert all of the disks to dynamic, including disk 0. As we go through this thing, we'll convert it. Are you sure you want to convert? Yes. Do you want to continue the operation? Yes. And this one should now ask me to do a reboot because I'm doing disk 0, the one that has the operating system on it. To complete the conversion, the computer will now restart. OK, and I'm going to pause while it restarts. Okay, the system is restarting, finishing the logon process. And now when we go to our administrative tools, computer management, disk management, we have dynamic disks. And what we have back here, Windows has finished installing the new devices. What it's done is now redetected the disks as dynamic disks, so it needs to restart again. That's what I wanted you to see, that we restarted it. It does the conversion, detects them, and then we have to restart again. So I'm going to say yes and pause while it does yet another restart. Okay, we've restarted for the second time, and I've started the computer management and am in the disk management console. Let's look at the options now. New volume. We can create a simple volume, a spanned volume, a striped volume, a mirrored, or a RAID 5 volume. Let's do a RAID 5 here quickly. RAID 5, you notice we still have the next. So if we add disk 1, we'll add, and we still don't have a next, so we have to add a third one, and now we have a next. In a RAID 5, we have to have at least 3 different disks. And you notice that it took the least amount of space that was available. When we had these disks, let's go back and remove all these again. We have 9994 on disk 1, so if I add disk 0, I get the full volume. When I add disk 1, which has 9994 available, it now says that's the maximum amount of space that can be taken from any of those. So it's going to be the amount of space that's available on the smallest drive. I'm going to put 250 meg in here just to make it small. We take 250 meg from each drive, and that's what the amount of space in megabytes, and this is from each drive. But the total volume is 500. So RAID 5 uses 1 disk space worth of storage in order to store the parity stripe. If we go next, and we can go here and do a quick format, and we'll call this one RAID 5. RAID 5, and finish it up. We should get the creation of the RAID 5 is creating the RAID and is formatting, and it goes across disk 1, disk 2, and disk 0. So it is distributed across these 3 disks. We can have between 3 and 32 disks for RAID 5. One of the other things that's kind of interesting, kind of helpful to be able to do with the dynamic disk in the server is in the operating system, the C drive here. If I right click on it, it says extend volume. But when I do that, I say let's extend the volume to these two. Finish this up. The operation could not be completed because this volume was created as a basic volume. When it was created on a basic disk. You can't, by using the software, extend the volume with the operating system on it. We can, however, add a mirror. We can create a mirror, and let's do that on disk 3, so that we'll go down here and automatically on disk 3 create a mirrored drive of the C drive, so that we, by one simple right click, can extend, or not extend, but make a copy of the C drive, so that if the operating system fails, we have a copy of it on a separate disk drive, on a separate disk itself. Again, if the whole machine blows up, lightning strike, sprinkler goes off, whatever else, both the original and the copy are now no longer usable. That's why we need to have a backup, so that the backup is stored from off-site. I'm going to pause this here. It's resyncing 1%. Going to take some time to copy the information or sync the information from the C drive to the disk 4, to this, or to disk 3, excuse me. That pretty much wraps up what I want to show you in the disk. Hopefully this has been useful. Thank you for watching. You can do a number of things with the operating system. These are software RAID, software conversion. The key to making the clever things work in Windows is converting the disks to dynamic disk. Once they're converted, we can use the volumes. We get away from the basic disk, the ability to manage the basic disk. We can now manage them as dynamic disk and create volumes. Again, thank you for watching, and hope this has been useful.